Hello everyone. Today's lesson will be about the basics of physics. So what is physics? Physics is a branch of science which deals with the study of matter and energy. So before we go into matter and energy, let's talk about physics itself. So up to class 5, we had just one subject of science, just science itself. But ever since class 6, we've had 3 different subjects of science, namely physics, chemistry and biology. So chemistry and biology, they are not part of today's discussion, so we'll just deal with physics. So matter is anything which takes up space or volume. So we've already learned about the 3 states of matter: solids, liquids and gases. So in solids, the particles are very close to one another. They're very tightly packed. In liquids, the particles are far away from one another. And in gases, they're very far away from one another. So these are the 3 states of matter which we are very familiar with. Moreover, matter basically contains atoms. So as we know, atoms are basically the smallest part of an element. So this is something we learned from the Greeks. But nowadays we know that atoms can even be broken down into small things like protons, neutrons and electrons. And if we go further into the A levels, we learn they are broken down to even smaller things called quarks. So these are solids, liquids and gases. So this wraps up the basics of matter. Now what about energy? Energy is the ability to do work. So whenever we consume food, we get the energy to work. So energy gives us the ability to do work. So we consume food. It could be, plants, it could be other animals. Animals themselves, they consume food. Food could be in the form of plants or other animals as well. Then cars also need energy to move, right? So cars get their energy from fuels, fossil fuels. Or nowadays we have, battery run cars which make use of the acid in the battery. So all of these things require energy to move. So without energy, nothing can do any work. So these are sort of the basics of matter and energy. So in physics, we need to measure things, and to do so, we need measuring instruments. So of course, to measure something, you need instruments. So what are the instruments that we need to measure different quantities is something we are going to discuss today in the next slides. So what is quantity? Quantity is the amount of things. It has 2 parts, magnitude and unit. So what is magnitude? Magnitude means size. So this is the magnitude, as you can see, and this is the unit. So we need both of them. So the number 41 by itself, it doesn't mean anything because it's just a number. What does it refer to? What are you referring to by, saying 41? 41 what? So 41 watt, that is where the unit comes in. So kg is the unit of mass. It's the SI unit of mass. So to express any quantity, you need to have both the magnitude and the unit. So these are the units which we use to measure length, time, mass and temperature. So length is usually measured in meters. Nowadays, meters. A meter is the standard unit for length. Centimeter is a smaller unit of meter. Kilometer is a larger unit of meter. And foot and inches, these are things which are used to measure height most of the times. So these are not that widely used. The other 3 are very widely used. And also nowadays in passports, our height is written in centimeters and meters, not in foot and inches anymore. Then time, we measure time in seconds. Seconds are the SI unit for time. So the larger units of time include hours, then days, then years. And the smaller unit of time includes millisecond. MS stands for millisecond. So the smaller unit of second is millisecond. So how small it is compared to 1 second, we'll learn this in the next few slides. Mass, the unit to measure mass, as we learned, kg. So kg is the SI unit for mass. Now the smaller unit of mass includes grams, milligrams. So how many grams make up a kg or how many milligrams make up a gram? These are things which we'll learn as well. So ton is a larger unit of mass. 1000 kg makes up a ton. And pound is a very archaic unit. Nowadays, no one uses pound, to be honest, but we'll discuss about it later as well. Temperature can be measured in any of these 3 units: Kelvin, Celsius or Fahrenheit. So Celsius is the most widely used unit of temperature. We use this in every day, weather applications make use of Celsius. Fahrenheit is basically the temperature unit which is used in thermometers. So when they say 100 degrees, it doesn't actually mean 100 degrees Celsius, it means 100 degrees Fahrenheit. Kelvin is actually the SI unit for temperature. So we have this common misunderstanding, the Celsius is the SI unit, but no, Kelvin is actually the SI unit to measure temperature. Now we move on to the SI units. What do SI units stand for? So scientists exchange measurements amongst themselves, and to do so they had to convert the units, because one of the scientists maybe is from France, another scientist is from England, another is from Asia. So different places, they had different units back then, right? So they had to come to a standard common point. Otherwise, they had to do conversions, and it was very, it was a lot of hassle. So they had to come to a common standpoint. They had to set a standard set of units. So this set of standard units came to be known as the System International Units, or in short, SI units. And this was basically approved by the scientists, and it was basically approved by a French group of scientists. So the full name, it's in French, but we shorten it up to System International Units. So we move on to the base quantities. So length is, like I said, the SI unit to measure length is meters, and the instruments used could be ruler or scale. Measuring tapes are used to measure larger lengths. Vernier calipers are used to measure small lengths, very small lengths. And micrometer screw gauge, it's used to measure the radius or diameter of circular objects or spherical objects. So the error which is made while measuring the quantity known as length is called the parallax error. So parallax error is basically what happens. It's like this: you have a scale, you have these gradations. Let's say this is 1, 2, 3, 4, 5. So if let's say the length that I'm measuring, it's actually from here up to here, so this much. So as you can see, it starts from 1, ends at 3. So that means the length is 2. The correct length is 2. But this is read wrongly if you look at it from sideways. If you look at it from a side, maybe in place of 3 you're going to see 4. And if you look at it from this side, maybe instead of 1 you're going to see 0. This is something which happens if you look at the scale from the sides. So to correctly read the scale, you have to look at it perpendicular. That means it has to be looked at directly. So if you look at it directly, it shows that the length is starting from 1 and ending at 3. But if you look at it from sideways, it might show 4 instead of 3, and it might show 0 instead of 1. So this is the parallax error. So you have to make sure that you look at it perpendicularly to the scale, directly at the scale. The unit to measure mass is, like I said, the kilogram, the kg. And you have to use an electronic balance or a pan balance to measure it. So electronic balance is something which we use in the super shops. So they have this machine, and on the machine they have you place the object, and if you place the object you get a reading here automatically. So this is an electronic balance. And the pan balance is a very old thing. Pan balance is basically what they have, two different scales on two different sides. So you place the thing you want to purchase on this side, and if you place this on this side, it sort of leans this way. And to balance this, you have to place known masses on the other side. So let's say to balance this, you place two let's say 5 kg weights. Two 5 kg weights you place on this side to balance this mass. So that means 10 kg mass is necessary to balance this mass. That means this mass is also equal to 10 kg. So this is a very manual method, and of course there is room for error because this thing might move right and left. So this is a error filled method. This is more accurate. So the problem which happens for the electronic balance is the zero error. So even without any mass, sometimes this reads something more than 0, because if there is no mass it should read 0. But even without the mass it reads some value. So that's a problem. So to get rid of that zero error, I mean the error which happens even though you have placed nothing, you still get a value. So to remove that zero error, you have to reset the instrument to 0. Now time is measured in seconds, and you can measure time using a stopwatch or a clock. And so what's the error that we make while measuring time? Human reaction error. So of course, while you have to start the stopwatch, so while starting the stopwatch, of course, you have to react first, right? Reaction. There is a human reaction. So your reaction, if you are young, most of the young people, they have very short reaction time. They react very swiftly. So the reaction time is small. But elder people, with age, our reaction becomes a bit lengthier, so our reaction time is a bit more. So this is something which can be fixed, adjusted by repeating the readings and taking the average. So if you keep on taking the readings, let's say you take the reading 10 times. So that means if you take the reading 10 times, by doing the average of the 10 times, the readings of the 10 times, you are going to basically sort of adjust or manage the human reaction time. It's going to be there, of course, but it's going to be much lesser, because with each click you become a bit more efficient. So the human reaction time will slowly come somewhere close to zero. So eventually the average reading will sort of reduce a lot of human reaction error. So temperature is measured in kelvins, and the instrument which we use, like I said, is thermometer. So like I said, thermometers, they don't actually measure temperature in Kelvin, but rather they measure in Fahrenheit. So like I said, 100 degrees Fahrenheit doesn't actually mean it's 100 degrees Celsius. It's around, let's say, maybe 37 degrees Celsius. Okay, so it's not much. Current is measured using the device called ammeter, and its unit is ampere. Okay, so these are basically the main quantities which we deal with in the SI unit. So these are the three main ones: length, mass, and time. There are so many such quantities. So these three are the main ones, and these are just used as examples. So these are the prefixes which have to be placed in front of the main units to understand how big or small they are. So prefix is, in English, it means anything which is placed before a term. So before a unit, if you place something, that's called prefix. So if we say tera anything, that means it's 10 to the power 12 times of that unit. Giga means it's 10 to the power 9 times of that unit. Mega means it's 10 to the power 6 times of that unit. Kilo means it's 10 to the power 3 times of that unit. Centi means it's 1 by 100th of that unit. 10 to the power minus 2 means 1 by 100th. Milli means 1 by 1000th of the unit, of the SI unit. Micro is 1 by 1000 of the unit. And nano is, there is something called pico as well. Let's say we write pico as well. Pico basically means P, and it is 10 to the power minus 12. So basically you're dividing this by 10 to the power 9. So it's 1 divided by 10 to the power 9th. And this one is 1 divided by 10 to the power 12. So this is the smallest they have gone up to, pico. So then these are a few examples. So if I show you, let's say I'm going to show you this one, number 6, how to convert nanometers to meters. So 95010 nanometers. So nanometers, what did we learn? Nanometer means, let me just rewrite this again. Nano means 10 to the power minus 9. If you look at this one, nano means 10 to the power minus 9. So you can either write it like this, or you can simply divide it. 10 to the power 9. You can either write it in standard form like this, or you can divide it. So basically, whenever you go from smaller units to larger units, you divide. See, we divided nanometers because it's a smaller unit and it's going to meters, which is a larger unit. So whenever we do so, we divide. Now, if we say we are going to go from a larger to a smaller unit, so let's deal with this one, 2 gigawatts. So 2 gigawatts means, giga means 10 to the power 9. So 2 gigawatts basically means 2 into 10 to the power 9 watts. So here we are multiplying, right? Here we are multiplying, and here we are dividing. So whenever you go from smaller to larger, you divide, and whenever you go from larger unit to smaller unit, you multiply. Okay. Now a few more examples. So let's say we go for this one. 100,100 watts. You're going to convert this to gigawatts. So it's going from a smaller unit to a larger unit. So that means we have to divide it. We divide this by how much? We divide this by, if we look at this one, giga means 10 to the power 9. So we have to divide this by 10 to the power 9. You can write it like this, or you can basically write this in a standard unit, 10 to the power minus 9. So both are correct. You can write it like this or like this. Both are fine. Now, conversion of time, very essential. So second is the SI unit for time, like we learned here, seconds. Now, if we look at this one, sometimes we have to convert from large units of time to small units of time, or vice versa. So if we are in this one, we are converting from days into seconds, so larger to smaller. So whenever, like I said, we go from larger to smaller, we multiply. So large is day is the largest, of course. So one day has 24 hours. So if you go from days to hours, that means you're going from large unit to small unit. So you multiply with 24 because one day has 24 hours. Then again, we are going from hours to minutes. So we are going from large to small units. So in an hour, there are 60 minutes. So we multiply this hour with 60. Then again, we are going from a larger unit to a smaller unit. So we go from minutes to seconds. That means we have to multiply with 60. Why? Because every minute contains 60 units. And as you can see, if you go the other way around, you have to divide. Why? Because you're going from a smaller unit to a larger unit. So if you have the time in seconds and you want to convert this to minutes, you have to divide this by 60. And again, minutes to hours, you're going from small unit to large unit, so you have to divide this by 60 as well. And here, hours to days, again smaller to larger, so you have to divide this as well. So the application that you have on this side, when you're going from larger to smaller units, if you go the other way, you just have to change it to a division instead of a multiplication. So this is something we sort of discussed in here. Okay, so this is basically the last one. Convert the following from 3 minutes to 4 seconds to seconds. So minutes to seconds means what? 3 minutes to seconds. So it basically means large to small. So we multiply 3 multiplied by 60 because in each minute there are 60 seconds. So we get 180 seconds. Then let's say we go from, this was a large to a small one. Let's say we go from small to large, seconds to minutes. So 120 seconds to minutes. So we go from small to large. So when you go from small to large, we divide. So how many seconds make up a minute? 60. So you cut them off. 2 minutes. So these are straightforward. So something else that we need to deal with, let me just erase this and show you people how to do it. So what if we have to deal with speed? Speed is something which makes use of both length and time. It makes use of both length and time. So let's say we have a car traveling at a speed of 20 meters per second, and we want to convert this speed to kilometers per hour. Okay. So whenever we go from small to large units, what do? We divide. So here we are going from meters to kilometers. That means small to large. So 20 meters to kilometers, that means you have to divide by 1000 because 1000 meters make a kilometer, and you are going from a small unit to a large unit. So you have to divide. Then we have what? Slash means division. Slash means division. Then we have seconds, and seconds getting converted to hours. So seconds getting converted to hours, it basically means you have to divide. Smaller to larger means divide. So here seconds to hours means you have to divide this by 3600. Why? Because in 1 minute you have 60 seconds, and in 1 hour you have 60 minutes. So it's 60 multiplied by 60. Okay, so 1 hour is basically 60 minutes, and in each minute there are 60 seconds. So by doing this multiplication, you're basically converting the hour to seconds. So this is what we did over here. We convert the seconds to hours by dividing. Why? Because seconds smaller unit, hour larger unit. So this is what we get. So if you cut them off, 0, 0, so you're going to get 72 kilometers per hour. Okay, this is what you're going to get. So what if we try the reverse? What if this thing, 72 kilometers per hour, we try to convert this to meters per second? What's going to happen? So of course, kilometer to meter is a larger unit to a smaller unit. So large to small means multiplication. So how much should we multiply it with? Kilometer to meter means larger to smaller, and each kilometer has 1000 meters. So we multiply this by 1000, and this is then getting converted to meters. Then slash means division. Hours to seconds, of course, hours to seconds means it's going from larger unit to a smaller unit. So again, we multiply. How much do we multiply this with? So if there is nothing, it means 1. Just like here we had nothing, so there was 1. Here there's nothing, so there's 1. So if there is nothing, you simply put there 1. Okay, and so that should be 1 divided by, if you're going from smaller to larger, and if you're going from larger to smaller, so 1 multiplied by. Okay, multiplication. So hour to second would be 3600, and if you do this, you're gonna get 20 meters per second. So see, you can go with this one, that will convert this to kilometers per hour, and if you try the reverse method, again you're getting the same thing back. So this shows that our calculations are fine. So this is how you convert from speed from a smaller unit to a larger unit, and then from a larger unit to a smaller unit. So in here we made use of both the length and the time. So this is something which is the complexity that you get using meters and seconds. So this is today's discussion. This is where we end it. Thank you so much for listening to it attentively. Thank you so much.